So today our group will talk about the steam engine. So for me, I will talk about the introduction of the steam engine, or we will talk about the history of the steam engine. So the invention and the refinement of steam engine play a central role in the development of the industrial revolution during the late 1700 century and early 1800 century in some of the major countries like England, Europe and North America. So the earliest version of the steam engine were used to pump water from coal mine in the England. How the pump work is, a pump is driven by a steam engine set on top of a mine shaft and burn the readily available coal to generate the power needed to remove water from deep in the shaft. So by doing so, we can generate power. For this steam engine, Thomas Newcomb invented the first successful engine in 1712 in England, which generally greatly increasing mining production. So from his invention, the mining is been increased greatly for the industrial purpose. After that, the next major investment in steam engine come in 1765 when James Watt introduced a refined steam engine that were more powerful and more efficient than the earlier engine that was invented by the Thomas Newcomb. The earlier engine used for pumping. The most important innovation introduced by Watt is that his engine used a piston to driven a wheel rather than a pump. So from the Thomas Newcomb, he used a pump, but for James Watt, he used a piston. Such a design opened the door for the Industrial Revolution, since steam engine could now be used in a wide range of application. By the early of 1800, steam engine had been further refined by other inventors and were small enough and efficient enough to power trains, boats and entire factory. Like it can also power the power plant that will also power the city. So
now I will explain about theory steam engine. A steam engine is a heat engine that performs mechanical work using steam as its working fluid. The steam engine uses the force produced by steam pressure to push a piston back and forth inside a cylinder. This pushing force is transformed by a connecting rod and flywheel into rotational force forward. The term steam engine is generally applied only to replicating engine as just described, not to the steam turbine. Steam engines are external combustion engine where the working fluid is separated from the combustion product. The ideal thermodynamic cycle used to analyze this process is called the Rankine cycle. In general usage, the term steam engine can refer to either complete steam plant, including boilers, such as railway steam, locomotive and portable engine, or may refer to the piston or turbine machinery alone, as in the beam engine and stationary steam engine.
The next is the components of the steam engines. The first component is firebox. Firebox is a furnace chamber that is built into the boiler and surrounded by the water. There are various combustible material that is used as fuel, such as wood, coke, oil, and coal. But the common fuel is wood or oil. For the next component is boiler. Boiler is a container that almost full of water with the airspace above it. The water is heated by the hot gases passing through the tubes and produce steam in the space above the water. Then the next is regulator. Regulator controls the amount of steam passed through the tube and delivered to the cylinder. One of the two ways is of the regulator is to vary the power of the engine. The next is cylinder. Cylinder is made pressure tight with the end covers and a piston, a valve, and distribute the steam to the end of the cylinder. Okay, the next component is piston. Piston is moved backward and forward within the cylinder by the steam pressure because of the steam expansion. For the superheater, superheater feeds steam back through boiler tubes to superheat the steam to increase efficiency and power of the engine. The next is valve. Valve controls the supply of steam to the cylinder. Valve position relative to the piston determined by the valve gear connected to the driving wheel. The last one is valve gear. Valve gear is a system of rods and linkage synchronizing the valve with the piston and controls the running direction and power of the locomotive.
Okay, now I will tell you about how steam engine works. Okay, first of all, burn the coal in firebox to heat the boiler. So inside the locomotive cab, you load the coal into the firebox, which is quite literally a metal box containing a roaring coal fire. So the fire will heat up the boiler. Okay, so it's the boiler is a big tank, contains water with dozens of metal tubes running through it. Okay, so the tube run water from the firebox to the chimney, carrying the heat and the smoke of the fire with them. So this arrangement of boiler tube means the fire can heat the water in the boiler tank much faster and more efficient. So the water that makes the steam either come from the tank mounted the side of the locomotive of a separate wagon called a tender, pulled behind the locomotive. Next, the steam generated from the boiler flows down into the cylinder. Okay, just ahead of the wheel. Okay, pushing a tight fitting plunger, which is the piston. We call a piston, back and forth. So at the piston, we get there are inlet valve to let the steam in. Okay, so the piston is connected to the crank and connecting rod to push the wheels. Okay, as the piston pushes, the crank and connecting rod turn the locomotive's wheels and power the train along. Okay, so when the piston has reached the end of the cylinder, it can push no further. So the train's momentum is the tendency to keep moving, carries the crank onward and pushing the piston back to the cylinder the way it came. Okay, so the steam inlet valve is closed and the outlet valve is open, and the pistons push the steam back through the cylinder to go up to the chimney. The choo-choo's noise that a steam engine makes and its intermediate puff of smoke. It happens when the piston moves back and forth in the cylinder. Thank you.
Okay, for the performance integration, I will talk about horsepower. There are many different reasons how a steam engine reaches maximum horsepower. It is depending on boiler design, superheating, piston, valve size, wheel size, and operating steam pressure of the boiler. Most of the railroad were most interested in effort and factor of adhesion to to the rail. Let me give you a couple of real-life examples of some steam locomotive. The small 606 Swiss engine was capable of producing 3,000 horsepower, and it was designed to be able to push or pull heavy cars of the train car around a classification yard at slow speed. But the Union Pacific big boys, for 884, it can produce to 6,500 horsepower and was designed to pull heavy trains over the Wasatch Mountain range at high speed. The horsepower range of other steam locomotive falls anywhere from less than 1,000 horsepower to 7,000 horsepower or more. But again, once we got past the 440 American locomotive, that was the mainstay of the early to mid-80s. Steam locomotives were specifically designed for different classes of services. Thank you.